Hello everyone, I am Ms.P.SATHIYAKEERTHIKA, Assistant Professor of Chemistry, A.D.M. College for Women, Autonomous, Nagapattinam. In this module, we are going to discuss about the topic in Unit 5 from Chemistry in Everyday Life for first MSc Chemistry, and the topic in dyes and dye chemistry. So now we will start the session. Today we will talk about dyes and dyeing process. So first, what is dyes? A dye is a colored substance that chemical bonds to the substrate with which it being applied. This distinguishes dyes from the pigments. So dyes must be color fast, soluble, able to bond to fiber and white withstand washing. There are several classification methods of dyes. So including by sources. So sources type dyes is natural versus synthetic. And chromophore types are nitro, nitroso and azo, triaryl methane and anthraquinone and indigo dyes. And the dyes are applications method. So direct dyes, wet dyes, mordant dyes, azoic dyes, dispersed dyes. So now we see the uses of dyes. So dye substance used in important color to the textiles, papers, leather and other materials, such as the coloring is not readily altered by washing, heat, light or other factors to which the material is likely to be exposed. So the previous topic we discussed about the topic in dyes, but now we discuss about the topic is dyeing process. So dye and dyeing process. So a dyeing process is the interaction between dye and fibers. So the dyeing process is interaction between dye and fibers, as well the movement of dye in the internal part of the fibers. So generally a drying process involved absorptions. So the absorption types are transfer of dyes from the aqueous solution into the fiber surface. And the another one type is diffusion dyes. The dyes diffused into the fibers. So next one, what is basic dyeing? The basic dyes are water soluble cationic dyes that are mainly applied to acrylic fibers but find some uses of wool and silk. So usually acetic acid is added to the dye bath to help the uptake of the dye onto the fiber. So the basic dyes are also used in the coloration of paper. So now let me see the topic is difference between dyes and pigments. So the dyes are water solubility nature is 70%, but the pigments are 100% water insoluble. So the dyes are directly affinity to the textile material, but pigments have no direct affinity to the textile materials. And next one, axochrome groups are present in dyes, but the pigments do not have the axochrome groups are absent in pigments. Most of the dyes are organic and the pigments, but most of the pigments are inorganic. So dyes are organic compound and pigments are inorganic compound. So dyes are highly cost effective. The pigments are cheap in cost. Number of binding agents are required. So the pigments do not have building agents is required in pigment. So dyes diffused in the fabric and pigments diffusions on the fabric. So pigments diffusions on the fabric. So and now we talk about Witt's theory. So in 1876, Witt proposed that dye molecules contain two groups. There are one group is chromophore group and another one group is axochrome. So the chromophore is a group of atoms which control the color of dyes. The chromophore group which control the atoms in the color of dyes at the time, which suggested that the axochrome was a salt forming group which helped to improve the color of dyes. According to this theory, the dye is made up of two parts, namely chromophore and axochrome. And the first one type is chromophore. The color of substance presence of unsaturated group is known as chromophore. So the chromophore is a colored substance present in a unsaturated group. Is known as chromophore. There are some examples of unsaturated chromophore compounds, that is nitro, carbonyl, ethylene and azo compounds. And the great number of chromophores are increase the intensity of, and the second type is axochrome. So first one is chromophore type and another one is axochrome. So the dyes must be attached to the fiber by means the stable chemical bonds. Those bonds are formed by some acidic and basic groups. The types of such basic groups are known as axochromes. Some examples of acidic nature of axochromes and basic nature of axochromes. Two types of axochromes are there, and one type is acidic nature and another one type is basic nature. So first one, acidic nature axochromes, for example, hydroxyl, carboxylic acid and sulfonate. And the another one, basic nature of axochromes are amine groups. Now we see the topic is classification of dyes based on the applications. So many classification of dyes are there, but now we see the classification of dyes based on their application. So the dyes are based on their application. The dyes are classified in following types. The following 6 types are there. So first one, direct dyes, wet dye, reactive dyes and moderate dyes. And fifth one is dispersed dye. So and the first one type is direct dye. So any of a class of colored water soluble compounds that have an affinity for fiber are taken up directly, such as the benzide derivatives, and the direct dyes are usually cheap and easily applied, and the dye can yield bright colors. So the first one type is direct dye is directly applied to the silk or cloths, and the dye yield in brightening colors. So the examples of direct dyes are some dyes such as indigo dye and lichens, so which give good color when used alone. These dyes are called direct dyes or substantive dyes. And second one type is wet dye. The second one type, the wet dye is water insoluble dyes. So this is a water insoluble dyes applied in a reduced soluble form and then re-oxidized to the original insoluble form. Once absorbed into the fiber, they are used to cellulose and some wool principally. And anthraquinone or indigo dyes are chemical group used. So some examples of wet dye is examples of included amalthine, benzantine, carbenthrine, and nevion and solanthrine. And the wet dye used, they are wetted, and the addition of sodium hydroxide and sodium hydrosulfide These dyes are dissolved in the water, are ionized and therefore do not produce the same color as the parent dyes. They not produce the same color as the parent dyes because they producing a different colors and new colors in the wet dye. So third one type is reactive dye. So the reactive dye is dye that can react with a fiber from a covalent link. That is forming a permanent attachment in the fiber and could not be removed by the repeated treatment. So the repeated treatment was with boiling water under the neutral conditions. So consequently, the dyes become part of the fiber, leading to the outstanding color, fatness to wash. And the pH of reactive dyes. So the optimal dyeing conditions were reported to be dye concentration of 8% on the weight of fabric for both the reactive and acidic dyes, and a pH of 3 to 4 at 110 degrees Celsius for reactive dyes, and the pH of 3 to 4 at 70 degrees Celsius for acidic dyes. And examples of reactive dyes are, the first examples of reactive dyes is utilized monoazo system for bright yellow and red shades. So the first one example is monoazo systems. For bright and yellow shades, they will be given. And coupling aniline to H acid give the azo dye used in first Prussian red. So they give the Prussian red color. And the anthraquinone dye were used to obtain bright blue shades. And the fourth one is acid dyes. And acidic dyes are acid dyes. The acid dyes are typically used to dye natural protein. So there are natural protein dyes that are used in wool and silk cloths, and synthetic polyamide, that means nylon, and two small extent acrylic and blended of this fibers. They are so called because they are applied to this fibers from dye bath and acidic or neutral conditions. An acid dye is a dye that is typically applied to the textile at low pH. So they use in textiles at using the low pH capacity. They are mainly used to dye wool. So they are mainly used in wool cloths only. They do not cotton fibers and cotton fabric. They do not use us. Some acid dyes are used as food colorant, and some can also be used to stain originals in the medicinal field. For examples of acid dyes, acid blue 25 and acid orange 5, acid orange 7, acid orange 20, amalthine dye, amido black 10B, and also rubine. There are the examples of acid dyes. And some advantages of acid dyes. The benefits of acid dyes are mainly to bond the protein fibers. Its affinity for staying softer and silkier. This is the advantages of acid dyes. They creating the films and cloths softer and silkier and weight to the wide application due to its solubility and light fatness of color. This fatness is useful to color is looking good. So fifth one is mordant dye. The mordant dye are acid dyes having chelating sites to form stable coordination complex with metal ions. From the metal salts are like mordant or the mordant dyes. The dyes can form chelates with different mordants to develop various shades. The mordant dyes are creating a various colors and various shades to the dyes with superior wash and fastness. And there are some examples of common dye mordants are tannic acid, oxalic acid, alum, chrome alum, sodium chloride, and certain salts of aluminium, chromium, copper, iron, iodine, potassium, sodium, tungsten, and tin. And sixth one is dispersed dye. And the last topic is dispersed dyes. The dispersed dye is a category of synthetic dye intended for polyester and related hydrophobic fibers. And the dispersed dyes are polar molecules. So this containing anthraquinone or azo groups. It is estimated that 85% of dispersed dye are azo or anthraquinone dyes. In examples of dispersed dyes, the dispersed blue dyes, especially 106 and 124, are create the common causes of contact allergy. So these dyes are reactively harmful to the humans to create the contact allergies. And dispersed orange 1 is an azo dye, and dispersed red 9 is a red dye derived from the anthraquinone. The red dye is derived from anthraquinone compound. And dispersed red 16 is also an anthraquinone dye. And dispersed yellow 26 is a yellow dispersed dye. And the pH of dispersed dye is the dye and the dye bath should be acidic and pH should be in between the 4.5 to 5.5. For maintaining this pH, generally acetic acid is used at this pH dye extraction is satisfactory. So, and the disadvantages of, now we see the disadvantages of dispersed dye. The structure of dispersed dyes contain ester groups which are easy to hydrolyze, and the dyes under alkaline conditions leading to the changes of light and dye loss during the dyeing. And now we come to the end of the session, and the session is over. I hope you all understand this topic. See you the next wonderful section, guys. Thank you.